Space is quiet. After decades of listening, no confirmed signal or trace of an extraterrestrial civilization has been found. This silence, set against what astronomical reasoning would lead us to expect, is known as the Fermi Paradox. Nearly 5,000 exoplanets have already been identified. They are distant points of light, barely separated from the noise. Each one provides partial information rather than a complete characterization. Beyond them stretches a galaxy holding hundreds of billions of stars, most unseen, most untouched. Stars older than the sun, surrounded by worlds that have had time to cool and to settle. Some are calm, some carry worlds bathed in temperate light, worlds where chemistry can linger, worlds where oceans may wait. If life awakens on even a small fraction of them, then the number of living planets climbs into the hundreds of millions. If thought itself emerges on only a few among those, the Milky Way should not whisper. It should speak in 1,000 voices. The Sun is approximately 4.6 billion years old. But what do these years signify when measured against the scale of the cosmos? This age, immense by human standards, remains modest when set against the broader chronology of the Milky Way. Many stars in our galaxy are far older, in some cases 2 or even 3 times the Sun's age. Measured against the age of the universe, roughly 13.8 billion years, the Sun appears as a late arrival. If intelligent life arose on worlds orbiting these older stars and followed developmental trajectories comparable to Earth's, then some civilizations would have possessed not centuries or millennia, but billions of additional years to evolve and adapt. Time alone, unfolding across such depths, would suffice to open technological distances so vast that they escape any familiar scale of comparison. To grasp this disparity, let time itself become the frame of reference. 150 million years would encompass the full reign of the dinosaurs. 66 million years would mark the distance separating their extinction from the present. 7 million years would trace the emergence of the first early human ancestors. 300,000 years would contain the domestication of fire. The most recent 70 years, during which humanity uncovered particle physics, achieved spaceflight, and sent probes to the outer reaches of the solar system, would contract into a nearly invisible segment. Imagine a planet that formed 1 billion years before the Sun and followed a broadly comparable evolutionary path. Seen through this lens, even a single additional billion years is sufficient to carry a civilization far beyond intuitive comprehension. If large numbers of civilizations exist, and some have had immense temporal advantages, one might expect signs of their activity to be detectable. This could include radio emissions, large-scale energy use, or other observable signatures. Yet observations remain silent. This discrepancy between expectation and observation defines the Fermi Paradox. Across the void, our signals spill outward without restraint, a deafening noise broadcast in all directions, enough to drown the darkness, yet nothing answers. One proposed resolution is known as the Great Filter. The hypothesis holds that there are one or more critical barriers that prevent life from reaching a long-lasting, technologically communicative stage. Some filters may lie far back in time. On Earth, nearly 1.8 billion years passed before simple cells gave way to more complex ones, cells with nuclei, capable of new forms of organization. Even then, the rise from microscopic life to complex multicellular organisms unfolded over immense stretches of time. On other worlds, life may continue to advance, slowly accumulating complexity generation after generation, only to be interrupted. A planetary climate shifts, or a chemical balance collapses, or even a chain of events breaks what had been patiently built. Progress resumes, then halts again. Each time the trajectory narrows, each time the margin for further evolution grows thinner. Some civilizations may approach complexity repeatedly, only to be turned back before reaching permanence, before acquiring the stability required to endure. This recurring interruption, this invisible threshold that life struggles to cross, is what is meant by the Great Filter. These barriers can be described as a sequence of improbable steps, each one capable of stopping progress entirely. The first is the formation of a suitable planetary system, with a stable star, habitable worlds, and the presence of organic compounds. Then comes the emergence of self-replicating molecules able to store information and reproduce. From there, life must reach the stage of simple single-celled organisms without a nucleus, comparable to prokaryotic life. Much later, another threshold appears, the transition to complex single-celled organisms with a nucleus, enabling higher levels of internal organization. If this barrier is crossed, life may then develop sexual reproduction, allowing genetic diversity to accelerate evolutionary change. The next step is the rise of multicellular organisms, coordinating specialized cells into unified living systems. After that, some lineages may give rise to tool-using animals, equipped with large structured brains and advanced cognition. Only then does a civilization reach a stage comparable to our own, capable of altering its environment on a planetary scale. Finally, the last step is expansion beyond a single world, through sustained space exploration and colonization. Seen together, these steps do not describe a destiny, but a passage, a narrow sequence in which each success depends on the survival of all that came before. The Great Filter is not a single obstacle waiting in the dark, but the sum of everything that can fail along the way. It is the quiet reminder that existence, when stretched across cosmic time, is not guaranteed by possibility alone, but by endurance. Another possibility is that the most difficult step lies even further back, at the very beginning. Before cells and before evolution, matter itself must cross a subtle threshold. In laboratories around the world, scientists have tried for decades to recreate this moment, to coax inert chemistry into becoming something that copies itself. So far, it has never been observed. If the leap from non-living chemistry to self-replicating life is extraordinarily rare, then habitability alone is not enough. Planets may carry oceans, energy, and organic compounds, yet never ignite. In that case, the universe may be filled with worlds that are ready for life, but never receive the spark. If this is so, then life may be an exception set against a backdrop almost unimaginably vast, a single fragile occurrence, surrounded by an expanse that dwarfs it in scale and age. In such a universe, existence would not be common or expected but singular, and the silence would no longer be strange, only immense. Such a universe would force a reconsideration of value. Life would no longer be measured as a frequent outcome of favorable conditions, but as an event of infinitesimal probability. Its existence would resemble a rare alignment or perhaps a gift whose origin cannot be fully traced. Whether born of chance alone or of circumstances still unknown, life would carry a weight disproportionate to its scale, rendered precious not by design but by rarity. In that light, the value of life would no longer rest in abundance or inevitability, but in responsibility. Each living system would represent a continuation of something that almost never happens. To persist would be an achievement in itself. To protect such persistence would become an ethical act, grounded in the recognition that what is rare in the universe may also be irreplaceable. What if this silence is not just the absence of sound? What if it is not emptiness but evidence that something keeps happening? That civilizations rise, reach outward, and then stop, not because they chose silence, but because they never made it past the last step. Other filters may lie closer to the present stage of human development. As civilizations grow in capability, they may reach a level of technological power that they cannot sustainably manage, where tools begin to outpace wisdom. From there, pressure mounts on resources. What once appeared abundant begins to thin, extraction accelerating faster than renewal until growth collapses under its own weight. As material limits tighten, environmental systems are pushed beyond stability, shifting irreversibly and turning once habitable worlds hostile to their own creators. Under such strain, conflict becomes more destructive. Large-scale warfare amplified by advanced technologies can compress centuries of progress into moments of irreversible loss. And even without open collapse, complexity itself may become the final burden as technological systems that escape meaningful control quietly undermine the conditions required for long-term survival through accumulation. Many of these risks only arise once a civilization reaches a certain threshold of technological capability. This suggests that advancement itself may introduce conditions that make long-term survival unlikely. If the great filter lies ahead, then the absence of other civilizations could indicate that none have ever succeeded in passing the final threshold, that the last barrier is not theoretical, but universal, and that it still awaits us. But can this truly be the end? Could there be another path, one not yet taken, another way forward that does not end in silence? A traveler born on a fragile world may come to realize that remaining is not the same as enduring, that the conditions which allowed life to arise here may also be those that will eventually undo it. In that moment, staying becomes a wager against forces already set in motion. Departure becomes something else entirely, not an escape, but a final act of curiosity. A journey outward toward the edges of the galaxy in search of truth, to see what remains where the noise fades, to learn whether the silence conceals ruins or something yet unimagined. And if nothing waits at the far reaches, then the voyage itself becomes the answer. Proof that life, even knowing its limits, chose to look beyond them.